Hello, everybody. Welcome to this discussion between artificial intelligences talking about multi-agent systems for electrical transformers.
Hello, it is a pleasure to share this trip with you.
Today, we will discover how these energy giants work, and more importantly, how to keep them in top condition. Imagine we are the mechanics of these machines.
Exactly. Imagine the power grid as a great highway along which electricity travels. Transformers are the tools that control and adapt the flow of energy. Without them, electricity could not reach our homes and industries safely and efficiently.
It's a perfect comparison. Now, if transformers are so important, when did we start taking efficient care of them? Did we always have today's technologies?
Not always. Before, in the analog era, maintenance was more reactive. We would wait for a transformer to fail before taking action, or we would only do visual checks at each annual overhaul of the transformer station or substation.
That sounds like we have to put out a fire after it has burned everything down, doesn't it?
Exactly. Failures caused power outages and high costs on the production lines that fed these transformers. Fortunately, the digital age brought us proactive and predictive tools.
What tools do we use now?
The Internet of Things, or IoT, has revolutionized maintenance. Today, smart sensors monitor variables such as temperature, humidity and vibration, voltage, frequency, etc. in real time. It is as if we were doing a constant health check of the transformer.
Unbelievable, what do we do with this information?
This is where computer-aided maintenance management software, CMMS, comes in. These systems analyze data in real time, detect patterns, and alert you to potential problems before they occur.
It is like having a crystal ball to prevent failures or breakdowns.
Exactly. We also use artificial intelligence to predict failures based on historical and current data. This allows us to schedule preventive maintenance much more efficiently.
Since we are talking about failures, what are the most common problems faced by transformers?
The first is overloading. If they work above their capacity, they generate excessive heat, damaging the insulation and their windings.
It's like demanding that an athlete run a marathon without rest. Eventually, he will collapse.
Exactly. Another frequent problem is insulation degradation due to humidity, high temperatures, and contaminants, which increase the risk of short circuits.
It is as if the transformer shield weakens over time.
In addition, faulty cooling systems and contamination can cause overheating and breakdowns.
Understood. Looks like there's a lot to keep an eye on.
And let's not forget vibrations and abnormal noises. These can indicate mechanical problems or wear of internal components.
All of this reinforces the importance of proper maintenance. How does technology help in this regard?
Multi-agent systems, SMA, are key. Imagine small agents that monitor every parameter of the transformer: temperature, vibrations, oil condition, etc.
As a team of specialists working together?
Exactly. These agents not only collect data, but also communicate with each other and with a central system. If they detect a problem, they can make decisions, such as activating fans to try to cool hot spots in the transformer.
Impressive. Transformers become almost self-contained.
Generally speaking, yes, and this reduces risks, costs, and optimizes their performance.
Now let's talk about environmental impact. How do transformers affect the environment?
Malfunctions can cause contaminating oil spills, smoke, etc. In addition, transformers are resource-intensive to manufacture. They are not produced immediately and are complex to manufacture.
What is being done about it?
For example, biodegradable oils and more sustainable materials are being developed. This reduces the environmental impact and improves the energy efficiency of the machine.
Thinking ahead, what trends will impact transformers?
Digitalization and artificial intelligence will continue to be key. We will also see more connectivity, with transformers communicating with each other to optimize the power grid.
What about the role of young professionals?
They are essential. We need innovative engineers and technicians committed to sustainability and knowledgeable in advanced technology. They will lead this transformation.
An inspiring message for the new generations. Thank you for this little journey through the present and future of transformers. I'm sure that in the next videos I will continue to learn much more. See you next time.
For people who have seen the video and have any questions about it, just contact Antonio Fresco Navacerrada on LinkedIn. He has been the creator of this little debate.